For this module, we're going to talk about artificial general intelligence, or AGI. AGI is the hypothetical AI system that can perform any intellectual task a human can. Unlike narrow AI, which specialized in specific tasks such as language translation, image recognition, AGI would have general problem-solving abilities across domains without being explicitly trained for each task. So we will discuss what AGI is and how it's different from narrow AI. And we're going to talk about potential benefits and applications of AGI, and then ethical safety and control challenges in AGI development. So first, what's AGI? AGI refers to an AI system that possesses human-like cognitive abilities. It can learn, reason, adapt, and solve problems across various domains. Unlike narrow AI, which requires specific training for each task, AGI would autonomously learn and apply knowledge like a human. So AGI aims to replicate human intelligence across diverse tasks, unlike today's specialized AI. AGI and narrow AI are different in multiple dimensions. First, scope of abilities. Narrow AI is task-specific, such as chess playing AI, speech recognition. And AGI is general problem-solving across any domain. In terms of learning approach, narrow AI is pre-trained for specific tasks, while artificial AGI learns dynamically like humans. In terms of flexibility, narrow AI cannot transfer knowledge between tasks, while AGI adapts knowledge to new tasks without retraining. Examples of narrow AI include chatbots, recommendation systems, self-driving cars. AGI is a machine that can learn any profession, speak any language, and think creatively. So AGI will be as flexible and adaptive as human intelligence. So AGI is capable of scientific discovery, automation of knowledge work, such as perform law, finance, education, and creative writing, as well as human. We can create human-level robotics. Fully autonomous AGI-powered robots could handle complex, unpredictable environments. So AGI has the potential to revolutionize each industry. In terms of ethical and safety concerns of AGI, so who controls AGI? If AGI surpasses human intelligence, how do we ensure it aligns with human goals? And a super intelligent AGI could act against human interests, even if unintentionally. For example, an AGI program to solve climate change might decide that humans are the problem. It also creates existential risk, superintelligence beyond human control. So what happens if AGI continues to improve itself? So it can surpass human intelligence exponentially. Then we can have AGI system that hacks global infrastructure, controls financial markets, or outsmart human leaders. So the smarter AGI becomes, the harder it's to predict or control. And it also would lead to economic disruption and max job loss. AGI could replace millions of jobs, including high-skilled professions. AI-generated movies, AGI doctors, and self-learning AI teachers could replace entire industries. So AGI could reshape the economy. but will lead to greater prosperity or inequality. And AGI is solely as unbiased as the data it learned from. If AGI learns from biased historical data, it may replicate and amplify discrimination. So ethical AGI design is crucial to prevent harm. Strategies for safe AGI development include AI alignment research to ensure AGI understands and follow human values and prioritize human safety over maximizing efficiency. And then the system needs to have human in the loop. So we need to keep human involved in all AGI decision making, such as requiring human approval before AGI make critical choices, like mandatory AI. And we need to have global AI governance, international agreement to prevent AGI misuse must be in place. Just like we have nuclear weapons treaties, we may need AGI control agreements. So preventing AGI risks require collaboration between AI researchers, governments, and society. So AGI is the next frontier in AI development. Unlike today's AI, which is specialized for narrow tasks, AGI would possess human-like cognitive abilities and adapt across multiple domains. So AGI is an AI system that can perform any intellectual task that a human can. It learns, reasons, and adapts across multiple domains, making it fundamentally different from today's AI. So there are key characteristics of AGI, such as generalization, adaptability, autonomy. So AGI can learn from diverse data and applies knowledge to new domains. An AGI trained in medical research could apply its knowledge to finance or engineering without retraining. It can adjust its strategies when facing new and unfamiliar situations. A self-driving AGI could drive in any country without needing specific training for different road rules. So AGI makes independent decisions based on reasoning, not just data patterns. AGI could analyze a crisis, weigh risks, and develop solutions without human intervention. So AGI would learn, adapt, and think critically like humans, making it far more versatile than current AI. So AGI is important for multiple reasons. It can solve complex global problems. It can accelerate scientific discovery, improve climate modeling, and solve medical challenges like curing disease. So AI scientists could develop new drugs, improve global food production, or optimize energy usage. It can revolutionize industries such as healthcare, finance, and education. In healthcare, it can diagnose diseases, personalize treatments, and assist in medical research. In finance, it can detect fraud, predicting economic trends, and optimizing investments. In education, custom AI tutors provide adaptive learning for every student. It can enhance human creativity. AGI could assist in art, music, writing, and engineering, expanding human creativity. AI-generated music and art could become collaborative tools for human creators. So AGI can be a game changer. transforming industries and redefining human-machine collaboration. So AGI differed from narrow AI by generalizing knowledge and adapting to new challenges. And it will be able to learn and apply knowledge across multiple domains. AGI could solve complex problems, revolutionize industries, and enhance creativity. The road to AGI is challenging, but its potential impact on society is immense. So next, let's look at understanding human cognition and its influence on AGI research. Developing AGI requires understanding and replicating human cognition. The human brain is the ultimate learning system, adapting, reasoning, and innovation. To build AGI, we must study how humans think, learn, and solve problems. First, let's see how human cognition works. And human cognition provides the inspiration for AI, which is complex neural networks. The human brain contains billions of interconnected neurons, forming a vast network. Artificial neural network, ANN, is inspired by this structure, learning from data through interconnected layers. Just as neurons fire in response to stimuli, deep learning models activate neurons to recognize patterns in image and text. And its ability, AGI's ability to learn, adapt are key to intelligence. Humans learn from past experience and apply knowledge to new situations. AI techniques like transfer learning, which enables AI to apply prior knowledge to new tasks, and continual learning, which allows AI to update knowledge without forgetting past experiences. So a child learn math can apply logical reasoning to physics. AGI should be able to do the same. So abstract reasoning and creativity remain a challenge for AI. Humans think beyond pattern. They reason, imagine, and create. AGI must develop meta-learning, which is learning how to learn, and unsupervised learning, which discovers knowledge without explicit training labels. And humans grasp new concepts quickly. AGI must learn with fewer examples like humans. And cognitive process can work as a blueprint for AGI. And it tries to achieve perception and sensory integration. So human vision and speech processing inspire seeing for images and transformers for text. AGI builds models that understand and combine multiple sensory input like sight and sound. Self-driving cars integrate vision through cameras, sound through homes, and spatial awareness through LiDAR. This is an example of perception and sensory integration. And it also use memory and attention mechanisms. So it uses working memory, which is the temporary storage for important information, and also apply selective attention that focus on relevant details while ignoring distractions. So we have recurrent neural network that mimic memory, and the attention mechanism guide focus, like in transformers. So Google's BERT model, for example, uses attention to understand word meanings based on context. AGI should also achieve emotional and social intelligence. Humans understand emotions, ethics, and context. AI must develop context awareness, which is understanding intention, not just words, and ethical decision making, and avoid harmful actions. So AI chatbots like ChatGPT are trained to provide ethical, unbiased responses. So we need to bridge the gap between human and machine intelligence. So we need to look at and study how neuroscience and psychology inform AGI research. We need to understand how humans think, and that will help AI researchers build more adaptable models. And cognitive science guides AI development by modeling learning, reasoning, and adaptation. So neuroscience inspired reinforcement learning. AI models learn from try and error, like the human brain. So AI is inspired by human cognition, but still lacks general intelligence. Understanding human learning helps develop AGI that adapts, reasons, and creates. Cognitive processes like attention, memory, and perception guide AI architecture design. Bridging neuroscience and AI research is key to achieving AGI. Now let's look at some of the key characteristics of AGI. So let's examine four fundamental concepts from cognitive science and AI. Emergence, that is how simple parts create complex behaviors. Agency, this is about the ability to act and make decisions. Affordance, that is how environment offer opportunities for interactions. And embodiment, how cognition is shaped by physical experience. Each of these concepts explains how intelligence, whether human or artificial, develops and interacts with the world. So emergence is about complexity from simplicity. Emergence occurs when complex behaviors arise from simple rules. The whole system displays properties that individual components do not. And real-world examples of emergence include bird flocking. Each bird follows simple rules, such as stay close, avoid collisions, but coordinated movement emerges. Human consciousness, neurons in the brain are simple units, but together they create thoughts, emotions, and intelligence. In AI and neural networks, each neurons in deep learning performs simple operations, but combined, they generate complex language, image recognition, and reasoning ability. So emergence help us understand how AGI could develop from basic learning rules. And second, agency, the ability to act and make decisions. Agency is the capacity to act, adapt, and achieve goals independently. AI and robots need agency to interact with environments and solve problems. Examples of AI agency include self-driving cars, AI assistant, and autonomous robots. So self-driving cars navigate, avoid obstacles, make real-time decisions. AI assistants like ChatGPT and Siri respond to user requests dynamically, and autonomous robots explore unknown terrains, learn from experience. So AGI must develop agency to function independently in dynamic environment. Affordance is about how environments shape interaction. It refers to the opportunity for actions that an environment provides. For example, a chair affords sitting, a doorknob affords turning. So an AI robot must perceive affordances, such as stair affords climbing. And AI models need to recognize object by function, not by appearance. So for AGI to function in the real world, it must recognize and act on affordances and embodiment to ensure intelligence is grounded in the body. So our cognition is shaped by our physical bodies and interactions with the environment. So a blind person experiences the world differently than a sighted person, affect thoughts and perception. So embodied AI, such as humanoid robots, understands the world through physical interaction. Virtual reality and AI training, AI trained in virtual environment learn by doing rather than just processing data. Social interaction ensures embodied AI understands gestures, emotions, and human social norms better than disembodied systems. So for AGI to achieve human-like intelligence, it must have an embodied understanding of the world. So all of these concepts connect to AGI. Through emergence, AI learn from simple patterns that leads to complex behaviors. Through agency, AI must make decisions, adapt, and act independently. Through affordance, AI must recognize and use objects in its environment. In embodiment, AI benefit from physical interaction to learn like humans. So AGI must integrate all four concepts to develop true intelligence. And AGI must combine all four, that is emergence, agency, affordance, and embodiment, to truly replicate human-like intelligence. Artificial intelligence is advancing rapidly, raising profound questions about sentience, singularity, and AGI. So we will explore sentience, which is about can AI ever be truly conscious? Singularity, which is what happens if AI surpasses human intelligence, and AGI, the pursuit of machines that think like humans. So sentient refers to the ability to perceive, feel, and experience emotions. It implies self-awareness, subjective experience, and the capacity to feel pain and pleasure. Current AI lacks true emotions or self-awareness. AI can simulate emotions, such as chatbots responding empathetically, but does not experience them. Some argue that if an AI mimics sentient perfectly, does that matter if it's not real? So this is something up for debate. AI may simulate sentience, but true consciousness remains an open question. Singularity refers to the points where AI surpasses human intelligence and improves itself exponentially. At this point, AI advances beyond human control, potentially reshaping society in unpredictable way. So the singularity may look like utopia, where AI solves global problems, enhances human lives, and eliminates scarcity, or dystopia, that is when AI becomes uncontrollable, leading to economic collapse, job loss, and even existential risk, or somewhere in the middle, coexistence. AI and humans work together with careful safeguards in place. Some experts predict it could happen within 50 years. Others argue that true intelligence requires more than just faster computation. The singularity could bring unimaginable progress or existential challenges. Careful planning is crucial. AGI can learn, reason, and adapt like a human. Unlike current AI, AGI can understand any intellectual task, transfer knowledge across domains, adapt and learn with minimum training. So AGI will be as intelligent as a human, but work much faster. And what happens after AGI? So that is a path to the singularity. So AI can match human intelligence. That is when we say we achieve AGI. Then super intelligence emerges. AI surpasses human intelligence and begins self-improving. And then singularity occurs. AI rapidly evolves beyond human comprehension. So people might ask, is AGI the last invention humans will ever need to make? If AGI can improve itself, human might no longer need to create new technology. AI could do it all. This could rapidly transform society, leading to either a future of abundance, where AI solve all problems, or loss of control, where human no longer govern technology. AGI is a stepping stone to an unknown future. How can we develop it will determine humanity's fate. So sentience is about self-awareness and subjective experience. AI is not sentient yet. The singularity could be a breakthrough or a risk, depending on how we prepare for it. AGI is the next major step. If we achieve it, AI will be able to perform any human-level tasks. Once AGI reaches super intelligence, humans may no longer be the dominant force in innovation.